Okay, we're live. All right, so we're going to look at alkenes today. Alkenes. Okay, and yesterday we looked at isomerism, which is not an easy topic, and we looked at something called geometrical. So these are on the video: geometrical isomerism, which is also known as you probably know, cis-trans isomerism, and it's also known as EZ, okay, which is a little bit unfamiliar with me, but you guys have got to know both terms. Cis-trans, cis means on the same side, trans is on opposite sides of the double bond. Remember, this isomerism only deals with carbon-carbon double bonds. Okay, and the E, as far as I remember, I might be wrong here, I think E is the opposite sides. So it's the other way around, and Z is the same side. Opposite side, same side. Yeah? Z stands for, what does it stand? Zusammen or something. It's a German word. And E is Enthagen. I can't honestly remember. This is quite a little bit unfamiliar to me, the EZ notation, but it's just as easy as cis-trans, isn't it? I'm more familiar with cis-trans, but you've got to be aware of both, okay? Okay, so now let's have a look at some reactions of these guys. Okay, now the first thing about alkenes that we obviously know is they contain a double bond. Okay, and as you both know, I'm sure you know this, if you looked at yesterday's videos, there's no rotation allowed around the double bond. All right, and that's why we get cis-trans or EZ isomerism. Okay, now more interestingly, what I think kind of more interestingly, is this area here where the double bond is, we have a high density of electrons. Okay, so often in chemistry we call this area electron rich. Okay, so the double bond itself has a high density of electrons. It is electron rich. Okay, and that means things are going to attack this that want electrons. Okay, so what's going to attack a high density of electrons? Well, positive things. Positive things are going to attack my double bonds. They're going to attack the double bond because the double bond is negative and positive things are going to attack it. Now, I'm sure you know this word, phile. Okay, phile means to like. Okay, and things that attack the double bond are known as electrophiles. Okay, electrophiles. All right, now, and now let me define that so you get that nicely. Electrophiles, they like electrons. They like electrons and will attack electron-rich double bonds. Okay, so an electrophile is something that will attack double bonds. All right, now, and they're going to attack alkenes, aren't they? So there you go, that's the first page of the notes, if you like. And I'm going to post this later, so it's up to you what you do with it. If you want to make notes of this, go for it. All right, now let's have a look at the reaction that you've probably seen before. Okay, there's a beaker. And I'm going to pass my gas, and the gas I'm going to pass is CH2, CH2. CH2, CH2, if you remember from yesterday, is a fancy way of saying ethene, and it's unsaturated. I'm going to pass this ethene through bromine water Br2 aqueous. And as you know from your Form 5 days, I'm sure, the bromine water will go from brown to colourless. Okay, and we say that an unsaturated hydrocarbon will decolour. Oh, that's not how you spell it. Let me get that right. Will decolour bromine water. Okay, and it'll go from brown to colourless. We know that. Okay, so what's happening then? Well, we're still on Form 5 stuff, aren't we? We haven't done anything clever yet. So you have CH2. It's going to react with bromine, and we're going to get CH2Br, CH2Br. Okay, now I've seen students do it like this before. C2H4 plus Br2 gives C2H4Br2. What's wrong with equation A? Can anyone see what's wrong with equation A? Anyone, just to keep you awake while I'm doing this. Oh, stretch. What's wrong with equation A? Anyone? Maybe you can't hear me, I don't know. Right. I'm not going to hang around forever. Does anyone know what's wrong with equation A? No. Okay. Equation A. All right, Lucky, well done. Thank you. IDK, or give me the answer, guys. All right. Equation A is ambiguous. Yeah, exactly. We don't know. Well done. It's ambiguous. Are the bromines attached to one chlorine, or are the bromines attached to two different? Sorry, what am I talking about? Are the bromines attached to one carbon, or are the bromine attached to two carbons? One each. Okay, so now let me redraw this. That's the nice blue color. All right, I'm going to redraw it now. We often draw it like this, don't we? CC. This is ethene. And I'm going to react it, as you can see, with bromine. Why do we keep changing colors? I don't know why. We're going to react it with bromine. Okay, and I'm going to get my product. And my product looks like this. Okay, and we get that. So anyone want to tell me what that's called? IDK, if you don't know, or if you don't want to answer. IDK is okay. Or a down thumb is even quicker, isn't it? A down thumb, if you don't know, well done, well done. Exactly, that's what it is. It is 1,2-dibromo ethane, isn't it? So what's wrong with this one then? What could that be? C2H2Br2. Sorry, C2H4Br2. What could that be? Anyone know? Why is it ambiguous? Ambiguous, it means it could be this or it could be this. I don't know which one it is. So if I say C2H4Br2, it could be 1,2-dibromoethane, but it could also be thumbs up, thumbs down. Anyone? No, maybe the internet connection. Longy doesn't know. That's fair enough. All right. Yeah, exactly. Timo, you're quite. Dimani, sorry, you're quite right. It could be 1,1-dibromo, couldn't it? And that would mean we'd have this C H Br Br. This one is 1,1-dibromo. This is 1,1-dibromoethane, and this one is 1,2. Okay, and they're not the same thing, so we can't do this. This is ambiguous. We've got to do this one. Okay, because the product is not 1,1, it is 1,2. So we're good with that. I'm sure you understand that. Okay, and that's the one that you've done in Form 5, if you remember. Okay, you might not know, or you may have forgotten that, I guess. Okay, so there you go. So we get 1,2-dibromoethane, and as you know, C2, CH2, CH2, ethene, this guy, ethene, is colourless. It's a colourless gas. But it's the bromine that's brown, isn't it? And this guy, 1,2-dibromethane, is colourless. That's why it goes from brown to colourless, because of the formation of that. Now, again, from Form 5 stuff, which you should remember, when A plus B gives one thing, C, that type of reaction is known as an addition reaction. Okay, this is an addition reaction. So we say the bromine adds to the ethene in an addition reaction. And an addition reaction is when two things becomes one thing. That's an addition reaction. Now, well, that's all very well and good, but unfortunately, guys, we've just done Form 5 chemistry. We haven't done anything clever yet, I'm afraid. Okay, so now we're going to do the clever stuff, all right, which is nice and straightforward, I think, but I hope you agree with me. Now what we're going to do is we're going to do the mechanism. Now, the mechanism shows you what's going on during the reaction. Now, yesterday or the day before, I can't remember, we did FRS, which is free radical substitution. And that's what happens to alkanes, isn't it? This is what happens to alkanes. But today we're going to do another mechanism, and today we're going to have a look at what happens to alkenes. All right. So first of all, before I go on, is everyone okay with what we're up to? Are we good? Are we good so far? Good stuff. Well done, guys. Right. Now, excellent. Nice one. Right. So now let's have a look at the mechanism. Now here is the mechanism. There's the double bonds. And there we are. H and H, and H, and H. Now what happens is the bromine comes along here, okay, and just randomly, just because of molecular movement and stuff, the bromine will just come next to, or will come along to the ethene molecule, all right? Now, because what's a nice color? We haven't used this green before. Because this region is electron rich, it means it has a negative charge. That region has a little bit of a negative charge. And what that's going to do to my bromine is it's going to push electrons away. It's going to repel electrons in the bromine. So electrons are going to be pushed to this side of the molecule. So that side of the molecule is going to be a little bit negative, and this side of the molecule is going to be a little bit positive. By the way, just in case we don't know, this is a delta, okay, and it means a little bit. All right, it looks like a strange S, doesn't it? But it's a delta. It means a little bit. A big delta, this is a capital delta, which means a lot. Okay. You've seen these before in chemistry and physics when we say delta T. That means change in temperature. If you do math, which I'm sure you do maths, you'd see dy dx, which is change in y divided by the change in x. Okay, dy, delta y over delta x means a little change in y divided by a little change in x. Delta y by delta x, that's a little change. But if we say dy dx, that's when the change becomes infinitesimal. Okay, so dy dx is at the limit of change. This is maths. This is nothing to do with us, is it? This is at the limit. And we use that in differentiation, don't we? So this is just a little bit of maths. And nothing to do with us, but it's life, isn't it? I like being overly clever. All right, I think you guys are clever, so you'll understand that. All right, nothing wrong with showing your brains. Okay, you two, I seriously hope you do incredibly well in your exams, but and I hope you go to a good university. Eh? My son is doing very well. He's going to UCLA in October, and you guys should be thinking along the same lines. Seriously, eh? Going to one of these posh ones on the government. All right, so think about that. Right, so anyway, let's get rid of this because this is not really for us, is it, for now? So let's get rid of that. Okay, so my bromine attacks the double bond like this. Okay, and there's a dipole now. So in the bromine, there's an induced dipole. All right, and as it gets closer and closer and closer to my double bond, the dipole will get more and more and more. Okay. By the way, the bromine molecule is now it has an induced dipole. It's going to attack the double bond more, and now we can call this guy an electrophile because now it's going to attack. Okay. So far so good. Are we good? Yeah, excellent. It's moving up. It's attacking the double bond. Now, well, as you know, mechanisms have got to show electron movement. So what color shall we use? We haven't used yellow today, so let's use yellow. All right. So these electrons are now going to come out and capture. They're going to capture that bromine, the top bromine, okay, because it's negative. And these electrons here are going to go onto my bromine molecule. Oh, sorry, onto the bottom bromine. Now, what type of curly arrow have I used here? This is a full curly arrow. All right, and now it's a full curly arrow, and because it's a full curly arrow, it means the movement of 2 electrons. Okay, so what's going to happen then? Okay, so we're going to get CH, and then a new bond. This is the new bond. Let me show the new bond in a different color. This is a new bond. Let me show it in the yellow. What the hell? Okay, this is the old bond. Now the electrons have left that now. The pi has opened up. All right, the pi molecular orbital has opened up, and it forms a new bond with my bromine. Okay, here it is. There. Okay, and what's down here? Br. A Br has been captured. Okay. Now, what happens to the other Br? Does anyone know? Anyone? What happens to the other Br, the one at the bottom? Now, unfortunately, this is when we should be at school really and talking about this. The bottom one is a special type of bond fission, and the bottom one has 2 electrons moving. So this is called heterolytic bond fission. Oh, what happened there? I think I pushed the wrong button. Can I get back to where I was? Not really. All right, this is called heterolytic bond fission. Bond fission. And if you remember from the other videos, if you have heterolytic bond fission, ions are formed. So the other bromine becomes this Br, and it has, we show it with 2 electrons, and it has a negative charge. And that's just a bromide ion, isn't it now? Yeah. Now, if the bottom one takes the electron, the top one, this one, and I don't want to draw too much on this picture, the top one, this guy, must be a positive ion, okay? And it goes up, and the positive ion joins this structure on the right, okay? And let me do a little thing again. Where is it? Yellow. And the positive charge will go there. Because if electrons have moved across to grab the positive charge, therefore the positive charge will go the other way. Does that make sense? Anyone? Yeah, you good? Oh, Tamani, you're not good. Okay. Is there a specific problem, Tamani? What's the specific? Type it down if you can. All right. Do you fancy typing it down? Tamani, if you want, you can put your microphone on for a second, and tell me what your problem is, or you can type it. Yeah, no problem. Okay, so what happens is this. The bromine attacks the electron-rich double bond, okay? And in doing so, the bromine becomes induced. There becomes an induced dipole, okay? As it gets closer to the double bond, electrons from the double bond go out and capture it. Now, do you remember, thumbs up or thumbs down, a full curly arrow means the movement of 2 electrons. Do you remember that? Yeah. And so a new bond will be formed between this carbon and this bromine. Are you okay with that? Because electrons come out to capture that. Okay. So you're good with that. And so we get this. All right. Now, let's have a look at this. Let's imagine this is coming up. You're asking good questions. Unfortunately, you're asking questions that are quite hard to answer. Okay, so this is the double bond, and the Br plus, because it becomes a Br plus because it is heterolytic bond fission, and you get ions formed. So do you understand a Br plus joins the molecule? Do you understand that? Excellent. Now, we're looking down here now. This is where we're looking now. So a Br plus comes along, okay, to join the molecule. This guy at the bottom is moving upwards, okay? This guy's moving up, this guy here. All right, now when it gets closer and closer and closer, these electrons come out to snap it up. There are the new electrons, but the electrons disappear from here. Yes? So now electrons have joined the bromine, and it's now the bromine is no longer Br plus because it's grabbed the electrons of the double bond. So the bromine becomes neutral. But that means since this carbon has lost the electrons, it is now plus itself. Because you've got to have the plus somewhere, and all that happens is the plus goes from the Br plus to the C plus, because of electrons have moved from one place to another. Does that make sense? All right, another good example. Supposing you are positively charged, okay? And I am neutral, okay? You're positive, I am neutral. I give you my electrons. What happens to you? You become neutral, and what happens to me? I become positive. So the charge, the positive charge, goes in the opposite direction of the electrons. Does that make sense? Are we good? Excellent. Yeah, but I hope it's, you know what, guys, it's not an easy concept, this is hard stuff, eh? Organic is beautiful, but it's hard. All right? Everyone takes it for granted. Everyone thinks, oh, you just got to remember loads of things. You don't. There's a lot of understanding. Don't understand the negative bromide ion. Okay, that's fair enough. But everything other than that, you understand. You're good with everything else. Yeah? Excellent. Right. No worries. Now, let me get rid of all of this rubbish. Okay. And we'll explain how that becomes negative. All right, no problem. This is quite easy, so this won't take long. Okay. So let's do my BR and my BR. All right. Now this is BR. There and there. So don't forget what happens is the electrons come from up here to capture this one. Okay. And these two electrons go onto here. So the top one now is this. Don't forget it doesn't have its electron. This is the top one, okay? And the bottom one grabs the electrons. So this one will be a positive ion, and this one will be a negative ion because it grabs the electrons of the original bond. Now this one, the top one, gets the electrons from the carbon. So that's what happens. But the bottom one becomes a Br minus. Are we good with that? Does that make sense? As long as it's okay, we think. What about you, Timani? Oh, hold on, I should have read that. So the other carbon is electron deficient. This one is, yes. Yes, it is. It's only got 3 electrons. It's only got 3 pairs of electrons. It's only got 3 bonds now, doesn't it? Does that make sense? All right, I hope so. You know what? Just let these ideas. It's like they've just got to diffuse into your brain. Eh? They're not easy to start with. I've been doing this a long time, so it's easy for me. But it's not. It's not an easy thing. Oops, that's gone wrong. All right, let me get rid of this rubbish, and we'll continue. Oops, that didn't work either. Oh God, everything's going wrong. Right there and bin. Excellent. Oops. So now. Oh, why is it doing this? Things are going wrong, guys. Right, I can't bring my page down. Why can't I bring the page down? What's going on? What do I have to do? I have to change it to that. There you go. All right, so this is the first thing. Excellent. It is understandable. It's hard, though. It's not easy. Now, what do you think happens now? What's the next stage of this mechanism? This is stage 1. And this is stage 2. What do you think happens in stage 2 now? Anyone? Anyone? Longy's thinking. All right. Those hard. Let me do it for you. The bromide ion is now minus, and now this attacks this, and the electrons go there. Now, what does this arrow represent? The negative one, exactly that. Well done, Tamara. So you understand that. Now, don't forget, this arrow here, I know this is very confusing. This arrow here, doesn't show the bromide ion moving up. It looks like it does, and the bromide ion will move up. The arrow in organic chemistry is very specifically to show electron movements. Okay, so that's a curly arrow, and it shows the electrons going up to join that. Well done, Tamani. So that is exactly what it is. So if the electron moves up here, we end up with what? Let's have a look. We should end up with this now, shouldn't we? So this becomes this. Oh, that's wrong. There's a bromine there, and a bromine there. In other words, this becomes our product. Is that good? Are we all okay with that? Excellent. Now, what's this called? What's this mechanism called? It does have a name, all right? And the name of this mechanism is, well, because the bromine attacks the double bond, this is known as electrophilic. Okay? Electrophilic means the first thing that happens is something attacks electrons. Electrophilic, and the whole thing is an addition reaction. So this is known as an electrophilic addition mechanism. Okay, so this one is known as electrophilic. This is an electrophilic addition mechanism. The first mechanism was free radical substitution. The second mechanism is electrophilic addition. Okay, and it's what happens when double bonds react. Is that okay for now anyway? Are we okay for now? Are we good? Excellent. Long as good. Good stuff. Now, this is what happens when bromine attacks. Now, I'm going to do exactly the same thing.